In this video, we're going to build off of what we just learned about relations, and we're going to add a special type of relation called a function to the mix. So remember, a relation that we saw before, it's just any set of paired inputs and outputs. So it can be any bunch of numbers, that's your domain, matched with any bunch of numbers that is your range. So it could just be any pairings. But a function is a more unique, limited set. Because a function, it's like a relation because you have pairings of inputs and outputs, but the difference is that each input must have only one output. So we're going to talk about what that means. And really, if this is confusing about the only one output thing, what you can think about it is a function is kind of like a machine. And you're going to put something into this machine, and if you have a machine that works correctly, that is consistent, that always does what it's supposed to do and never has any bugs or any sort of weird oddities to it, it's always going to produce something that should be consistent, right? So if you were to put in something into a machine, it should always produce just one thing. If you had a really strange machine that was unpredictable, maybe it would produce two different things, but our function machine only produces one output. So we're going to see what that means. Here are some examples of relations and functions. In each pair here, there is one function between the two relations. So all of these things are relations because they're a set of inputs matched with a set of outputs, but only some of them will be functions. And so let's talk about why that is. So here let's take a look at my maps first. What I'm going to do is look at the inputs and see how they map to outputs. So over my first example, the 2 maps to a 1, the 4 maps to a 1, and the 6 maps to a 3. So if this relation is a function, then each input must have one output. Well, let's see. Here's an input, and it looks like it has only one output. It only outputs to 1. 4 only has one output, and outputs to 1. And 6 only has one output, and that outputs to 3. So then this thing is a function, since it passes this test. Now let's take a look at this relation here. So in this relation, the 2 maps to a 1. Looks like the 4 maps to a 1, but the 4 also maps to a 3. That's going to be a problem here. And then the 6 maps to a 5. So you'll notice that the 2 maps to one thing, the 6 maps to one thing, but this 4 maps to two things. And since that input has more than one output, this thing is not a function, it is just a relation. And so when you're looking at these mappings, really what you're looking for is the number of arrows coming off of your inputs. If you have a function, you'll notice every input has only one arrow coming off of it. That means that it would have one output. That's a quick way to look for that here. Next up, we've got a couple of tables. These are relations again because there are pairings of x's and y's. So let's see if we have one input, or rather one output per input. So let's say we've got a 1 goes to a 3, a 5 goes to a 2, a 6 goes to a 2, and a -9 goes to 3. So it looks like I've got 4 different inputs, and each one of these different inputs relates to just one thing. So that's going to pass my test. It looks like every input just has one output. So this is going to be a function. All right, next let's take a look at this relation, this table here. I've got 3 matching to -1, 9 matching to -2 or to +2, 1 goes to 5, 3 goes to 3, and -5 goes to 2. So what we're looking for here is repeated inputs. So I have 5, 1, 2, 3, 4, 5 inputs, but there's really only 4 unique inputs. The 3 shows up twice. And what this means here is that 3, my input, can either become a 1, or rather a -1, or it can become a -3. So that means for this one input, I can have two different outputs. So that means that this is not a function. This is a relation, they both are, but this relation is not a function since I have a repeated input in my table. So that's kind of what you're looking for with your tables. Next, let's move over to our ordered pairs. And with our ordered pairs, again, it's kind of like with the table here, we're going to look at our inputs. So I've got a 0, I've got a 2, I've got a 2, I've got a 4, and a 4, and a 4. So between all of these inputs, I really only have 1, 2, 3 different inputs, since I have a 0 that shows up, a 2 that shows up, and a 4. There are no other different inputs. And since I have only these 3 inputs but 5 different outputs, that's going to mean that one of my inputs has double, or not double, but multiple outputs. And that's in fact the case with 2. 2 can either point to -1 or 2 can point to 3. Since this input has 2 outputs, this one is not a function. Same thing with 4. 4 now, that one input can point to either a -1, a 2, or a 4. So that breaks this thing down. A general rule with your ordered pairs is you want to look at all of your inputs. If the number of different inputs is less than the number of total pairs, you're not going to have a function on your hand. So let's look at the second one here. I've got a 0, I've got a 1, a 5, a 4, a 2, and an 8. So right off the bat, these are all 5 different inputs. Nope, miscounted here. That's 1, 2, 3, 4, 5, 6. 6 different pairs, or ordered pairs, and actually that's going to be 6 here too. So since I have 6 different pairs and 6 different inputs, then this thing's going to be a function. No repeated inputs. So that's going to be a function here. That one works out. And what you will notice though is we do have repeated outputs. I see a -2, or rather a +2 and a +2. I even see a +3 and a +3. That's okay. Repeated outputs is okay. I may not have repeated inputs. So that's something important to distinguish here. And then finally, to distinguish in a graph if you have repeated, or rather a function or not a function, what you're going to look at is, again, each input must have only one output. And what's going to key us into that for our graphs? Remember, the input is your x values, and the output is your y values. So what you're thinking about here is if you were to move along the x-axis, you're kind of looking at your different inputs, and you want to see how many outputs they produce. So if I were to grab -2 here as an input, it's going to output whatever this value is right here. If I were to look at, this looks like -1 as an input, it's going to output just that one value here. And if I were to go all the way along my x-axis and find the related outputs, I'm only seeing one output per input. So this is going to be a function. Now let's take a look at this graph here. If I follow my inputs, my x-axis, and let's say I were to grab this input right here at 2. When x equals 2, the graph, or the output, produces not 1, but 2 outputs. So this, in fact, will not be a function. And the shortcut for this type of graphical test, a graphical approach, is what we call the vertical line test. Let me scroll down here. You want the vertical line test. We'll talk about the vertical line test in the next video.